Yes, sir.
Okay. Today we will just complete the topic we were discussing till yesterday, that is one-dimensional array and two-dimensional array. And further, I will not start a new topic. Rather, we will discuss if you have any doubt regarding any of the test portions, any or in any topic. If you have doubt, we will try to clarify. Okay. And if nothing is there, I'll leave you early and you can prepare for the test. So, yeah. So what we were discussing was two-dimensional arrays. So, maybe comparatively the complexity of the topics have increased. We started with very simple programs, and then we went on to branching statement, if switch, etc. Then we went on to looping statement, then moved on to arrays, which uses looping again in a single loop or in a nested loop fashion. For one-dimensional array, we required only simple loops, but two-dimensional array requires nested loops for taking input, processing it, as well as uh, displaying the output. So, but still there is a definite pattern whenever it is a one-dimensional array. What mostly you require is a single level, one level loop only. So, based on the number of elements, for I is equal to 0, I less than n if number of elements is n. So we create a sufficiently large array, single dimensional array, but the actual number of elements stored in that array will be less than or at most equal to 20. Okay. So you create a sufficiently large array, but the actual number of elements stored in that array we will decide by taking the input from the user. Then the loop pattern is for I is equal to 0, I less than the actual number of elements you want to store. Why less than? Because we are starting I value with 0. Excuse me. I value with 0. If we had started I value with 1, we would have put I less than or equal to. But the problem is that array indexing starts from 0. So we want to use the first element of the array, that is num 0. For that reason we are putting I is equal to 0 and upper bound is maximum n minus 1. I can take maximum n minus 1. That is the legal upper limit of the array. If 20 is the size, nums 19 is the last element we can legally use. Nums 20 is not usable, or we should not use that. That is the reason why we are starting with I is equal to 0, I less than n, rather than using I is equal to 1, I less than or equal to n. Okay, we start with 0 and go until n minus 1 for the value of I. Now only one loop, no nested level looping. But when it comes to two-dimensional array, since we have rows and columns, we use nested loop. The inner loop used for selecting the column, outer loop is used for selecting the row. So we select the first row, then we use the inner loop to fill all the elements of that row by changing only the column value. Okay, when I is equal to 0, for j equal to 0, 1 and 2, if it is a 3 by 3 matrix, 0, 1 and 2, this loop will be executed. Then 0, 1, 0, 2, 0, 0, 0, 1, 0, 2. I value will remain same, but column value only will be changed. That way we populate the first row. Then we increment the value to 1, and when I value is 1, that means the second row is selected, and we keep changing the value of j, the column value, so that we populate the second row. This is the way we populate the elements. Then for accessing each element, the same pattern is used. Rows are selected using the outer loop, columns are selected in a particular row, columns are selected using the inner row. Again, we in the next iteration of the outer loop, second row is selected, and all the elements of the second row will be selected using by the variable j, this way. So if you see this, the first indexing we use I in that loop. For second indexing we use j. So in a row, row index remains same. We don't vary the row index, only the column index is changed using the variable j. J is equal to 0, j is equal to 1, j is equal to 2. Then again, in the second iteration of the outer loop, I value becomes 1, I value becomes 1. So 1 0, j value is 0 here, 1 0, I is equal to 1, j is also 1, 1 1, 1 2. And these locations, elements are stored. Elements are stored in the second row, like that. Is this clear for everybody? If you have any doubt, you can ask, because we have many programs related to matrix addition, matrix multiplication. Yeah, these are so matrix are basically we use two-dimensional array for matrix kind of data, where rows as well as columns are there. For linear sequence of data, we use one-dimension array. Is it clear for you? Any question? So can I assume that you understood this? So today we have some time, we are not pressured by completing the topic because we are almost done. Just want to clarify. So you have to be comfortable with this. Try to work it out, probably mentally you try to work it out in mind. Okay, first element based on this diagram. This is a matrix. The cells are marked by row index and column index. 0 0 means first cell, 0 1 means second cell in first row. First cell in first row, second cell in first row. And I'm in this order I'm going. In this order I'm going. Then take the next row, and again in this order I'm going. In this order I'm going. That is what is done by this loop. The same thing is done by same loop is used here also. But here, rather than taking the input from the user, I am processing the data. Minimal processing we did yesterday, that was doubling. Each element will be doubled and stored in the same location. So 2 becomes 4, 4 becomes 8, 6 becomes 12, like that. Basic processing we are applying. And the modified matrix we displayed. Okay. If it is 2 by 3, I have to enter the elements now. 2 rows, 3 columns. So in a row there will be 3 elements. 1 2 3 7 8 9. So this is the input. 2 by 3 means 6 elements are required. This is the, just to look it better, I am entering in 2 lines. Using enter key, I am entering it in 2 lines. And when I am displaying, I am taking care that the output is displayed in the form of a matrix in 2 lines. For that, what I do, after the inner loop is going to print one row, after that I am simply printing new line character, so that the next row, in the next iteration of outer loop, the next row will come in a new line. Okay, if I simply remove this, if I commented this, the output would have been different. It would have come in same line. I am just removing commenting this line, so you can see how the output comes. Okay, I'll put it here. So the doubled output is coming as a linear sequence rather than if I want it as a like in the form of a matrix in different lines. I can enable this. Okay. Now here I put a single space, that is why the output elements are coming in with a single space of gap. Instead of that I can put a tab character also. Tab is a group of blank spaces. Okay, /t. So this is a special character we have learned. So what if I do that? What if I do that? Now the result looks better. The organization of the output looks better. Okay, equal spacing between first and second number. The additional digit for the second row is here. It looks better. Okay, so formatting output, sometimes you can use tab character which will do some kind of alignment of your result. Any question about two-dimensional arrays? So I told this will be your basically same code is displayed here. Since it was exceeding one page, I just splitted this window so that this code, see this output, this is same as here what you see here. Okay, this is the complete program, but some code is repeated from line number 12 to 26 is repeated here also, but after that you have the remaining code. So if you want to take a snapshot of this, you can take, so that the complete program is there, but mindful of the repeated code, line number 12 to 26, it is appearing here also. Otherwise I'll have to scroll down and show you, rather than I wanted to fit it in one window so that you can take single snapshot. Okay. Any question? I expect some interaction from you today because I don't have much things to cover other than this. Any question? So this is your assignment as well. Okay, yeah, 14th assignment problem. So can somebody tell me, what if I want to find the sum of the elements in the array matrix? So I entered a matrix. If I want to find the sum of the elements in the matrix, what should I do? Find the sum of the elements in the two-dimensional array or matrix. Can someone suggest? Nobody? That means you did not understand this. Can someone unmute and suggest me how to find the sum of the elements in the matrix? Nobody is able to tell. It's a very small change actually in the processing part. Input remains the same. We get all the elements and store it into the two-dimensional array. In the output, in addition to the modified matrix, probably we will find the display the sum also. After this, I can display sum of elements. Sum is percentage d. How do I find? Nobody is able to tell. I will be disappointed. So what I will do is, I'll create a variable to store the sum. Okay, sum, and initialize it to 0. As of now, sum is 0. Now here, in the place of doubling it, instead of doubling, let's forget about doubling it. Rather than, what I am going to do is sum equal to sum plus ARR or ARR of ij. ARR ij. So here actually array ij, it is accessing every element in the two-dimensional array because we keep changing the value of I and j. Initially 0 0, then 0 1, 0 2, then 1 0, 1 1, 1 2, assuming a 3 by 3 array. 1 0, 1 1, 1 2, 2 0, 2 1, 2 2. So every element in the array is accessed here. So the moment I access it, I cumulatively add it into the sum variable. Okay, this step is enough. Remember that when I do a statement like this, or if I do simply aij, I am accessing array ij, I am accessing by changing the value of I and j, I am accessing every element in the matrix, element in the stored matrix. So if I have every element in my hand, I can keep on adding it to a variable. First time sum will be sum is equal to 0 plus first element. Then the sum is assigned to this variable, or this sum value is, the existing value will be overwritten by the sum. Next time the accumulated sum so far will be added to the next element. So this way we keep on adding each element to the cumulative sum we obtained so far, and finally we get the sum of the elements. Okay, so what I did only one line change and I get sum of all the elements in the matrix. So if I put 3 by 3, sum is 45, and I am not doubling it. The exact same array I entered, I get at the output, because the doubling statement I removed. So every element will not be doubled now, rather than the current processing is we are finding the sum of the array, sum of the elements in the two-dimensional array or the matrix.